Welcome back, everyone. I hope you enjoyed your lunches because now we're back for some more awesome talks. This next one is called Sparking Creativity and Joy in LED Art with CircuitPython by Debra Ansell, who has been building LED art and wearables for over a decade and is the author of the popular Geekmon Projects blog. Sorry. Welcome, Debra. We're
Thank
so
you.
happy to have you here.
Thank you so much. And of course, my dog picked just this moment to make a pass through my office. Give me 1 second. Of course she did. Go, dog, go. Okay, I'm ready. Thank you.
Dogs out. The stage is all yours. Have a good
Wonderful.
talk.
Thank you so much. And all right. Hi, everybody. I hope you're enjoying the conference so far. My name is Debra Ansell, and I like LEDs, especially programmable LEDs. I found them to be a wonderfully creative medium, and I'm here at PyCascades because CircuitPython is an incredibly useful tool that helps me bring my LED project ideas to life. So having explained all that, there's only one thing left in the intro, I'd like you to think like Fabrizia just did, so I can say, just welcome to my LED talk, and thanks for coming. I've always wanted to say that. Okay, so this talk contains 2 live interactive demos. The first, I'll demonstrate right now. There is a table of several LED art projects behind me. There's 3 in particular running similar animations, and they are Twitter connected. So if you actually send a tweet anytime during the talk, and I'll demonstrate now, that contains any of the CSS color words, you can Google what they are, but they're pretty standard color words, not, oh, I think somebody just did it already. Any of the CSS color words, and the hashtag PyCascades LED, the display will change. So for example, I can type I like green, PyCascades LED. I'll actually, just in case I've used this. Oh, okay, you guys are all beating me to this. You guys are much faster. Oh, wait, no, I'm looking at it on the display. Sorry. Here, I like green, PyCascades LED. And I click tweet. And I count 3, 2, 1, and look at the display behind me. Boom. There, it shows updates on the display. So you can tweet a combination of a CSS color. I was looking at the slide and getting confused, but I'm oriented now. So yes, the displays behind me will change color if you send a tweet with a CSS color word and the hashtag PyCascades LED. You can't use RGB or hex, and I think I'm on a 20-second delay. So what for me is a 3-second delay will probably be a 23-second delay for you. But you should still do it because it's fun. And if you see the colors changing behind me, it's not me doing it. So the second demo will take place after about the first 10 slides. And I'll be actually doing some live coding demonstrations of LED animations using CircuitPython. And if you want to code along, if you have a CircuitPython enabled microcontroller, you can actually do the code in real time with me. I've put the files up at this link on my GitHub, my Geekmon Projects GitHub. There's a PyCascades repository, and you can download the files you need there in the libraries with a little explanation. And you can also use this bit. This is the same link, just bit.ly. And if anybody wants to copy this into the chat for others, that might be helpful because I'm going to change the slide now. So back to CircuitPython and creativity. So I've always been a creative person, and as you can see, I like making things. But over my life, have learned the hard way that creativity and artistic ability do not always come paired together. So I'd think of these great projects in my head, and they'd never quite meet my expectations. And over the course of my lifetime, here are a few of my not quite there attempts. And yes, some of these are early childhood, but really things haven't improved much since then. So it wasn't until I really kind of found my medium that things got better. And ironically, I got turned on to my creative medium by coaching my son's robotics team about 10 years ago. And that's when I learned about Arduino. I'd worked in software, mostly C++, but had very little electronics experience. I was immediately fascinated by physical computing. I'd started reading Arduino blogs and building examples I saw there. And throughout this process, I also learned about design using CAD and how to code different kinds of LEDs. So these videos and this picture are some of the first projects I made. They were all copied directly from tutorials I found online. And that's how I learned, just copying other people's tutorials. And for me, combining these three concepts, Arduino CAD and LEDs, coding CAD and LEDs, created a whole world of possibilities. And after a while, once I felt comfortable copying other people's designs, I started to experiment. And then it turns out, when you find your niche, it's fun and it's hard to stop. So it turns out for me that microcontrollers, digital design, and programmable illumination produce endless permutations of possibilities. And my aesthetic and my goal when creating LED art is to use the light almost like paint, to try to spread it around, not just kind of pinpoints of light, but to diffuse it. And a lot of my projects that you can see here and behind me are edge lit, where you put the illumination at the edge of a diffusive medium like acrylic or fiber optics or even hot glue. And that creates an area that fills with a diffuse, colorful glow, which I really like. And another area I'm very active in creating projects in got started when I first started with Arduino and used their LilyPad board, which allows you to sew electrical connections with conductive thread, and that got me hooked on wearables. I really, really like making projects that you can wear because you get to take them with you wherever you go. It makes your clothing just that much more fun. The upper right project is an infinity mirror necklace I recently wrote up for Adafruit in their Learn Guide, and that's something that anybody can make. So I like creating wearable projects, ideally that others can make. And the nice thing about making wearables is if, like me, your sewing skills don't quite match your goals, once your projects are lighting up, nobody is looking too closely at the seams that you've sewn. So all of these projects are possible because of microcontrollers. Every single project I make uses one. They have become increasingly small and cheap and easy to code and accessible through the years. So these picture groupings show 3 microcontrollers I've used in different projects. The microbit is designed for education and is really fun to use. I teach Code Club with it. The Adafruit Gemma M0, which is actually running my headband right now, is designed for wearables. And here's a picture of an LED Mobius strip I'm using run that's controlled by the Gemma M0. And this new Raspberry Pi Pico board came out recently. It's super powerful. It is dual core and it's $4. So you can buy a bunch of them and just leave them in your projects. And it's wonderful, wonderfully easy to use for embedded projects. So with microcontrollers and with the increasing speed and power of microcontrollers, it became possible to use Python on them. And Python on microcontrollers started with MicroPython, which is a very small open source implementation of Python 3. It's an interpreter that can run on a microcontroller, and yet it still retains most of the really interesting features of the Python language, including classes and weak typing and all sorts of things. Beyond MicroPython, there's CircuitPython, which is another open source, so both open source derivative branch of MicroPython that is educationally oriented and hardware focused. So what that means is, first of all, they have a lot of Learn guides wrapped around it. It's a great way to learn physical computing with Python. And the hardware focus means they write libraries for all sorts of hardware peripherals, including LEDs, that make it super, super easy to run them. And their goal of platform independence let you to use the same code across different kinds of microcontrollers with almost no changes. So I have found that CircuitPython makes a wonderful match for LED art projects. Because it's dynamic and interactive and gives you real-time feedback and updates. And the Powerful libraries let you add a ton of functionality with very little code. And I'd had a great deal more written about CircuitPython, but somebody looked over my slides and basically, in not so many words, said, you know, show, don't tell. So I think it'll be nice to explore some of the features and functionality of CircuitPython by actually coding some projects themselves. And again, if you went to my GitHub, Geekmon Projects GitHub, and downloaded the files, you'll be able to code along with me. I am going to close up the PowerPoint and actually open up, hopefully we'll switch to my project camera right now. And there's my project cam, great. And we'll demonstrate how to code CircuitPython LED animations in some of the libraries, using some of the CircuitPython libraries and functionality, which I really love. So the first project we're going to do is this, let me turn it on, is this animated LED baseball cap. And it is a simple project. I've written up how to build it on my blog. And it contains a single LED strip, 12 LEDs, and it was really easy to wire it just inside to a CircuitPython running Gemma M0 board right here. And I'm actually purposely starting with the demo with this Gemma M0 because CircuitPython is bigger and more resource intensive than, say, programming in C and certainly than assembly. So there are limits to what you can do on the smaller boards. With the newer, faster boards, you can do more. So we're going to do as much as we can for on this hat, and then I'm going to switch to a different controller to do some even more advanced animations. So let's get started. So you can see it's running a CircuitPython animation now. And so let me show you the nice thing about that I love about CircuitPython. Let me close these up. If I unplug and plug the hat back in, okay, so yeah, if we can have, I think we'll probably need two windows, one my desktop and one the hat, and you can make me really, really small if possible. If you plug it back in, a browser window pops up, a file browser window, and the CircuitPython, if you can't read it, you can try it yourself with your own CircuitPython board, shows up as a connected drive. And to get your code and your libraries on there, it's literally drag and drop, and it couldn't be easier. I love how easy that is. And so let me show you, let's do an example of that, because I've coded up this hat a little bit. So I'm going to start you with a demo code. Oops, let's grab another File Explorer window. So if you have downloaded the code and libraries from my blog, you can follow me here to install them on your CircuitPy drive. So I went downloads, PyCascades. Okay, here are the files I downloaded, and okay. So for example, on my CircuitPython drive, I can delete the code, the Python file, and the libraries folder, and I can drag over the ones I want. Because this is a small microcontroller and doesn't have a lot of memory, I'm going to use the bare bones version of the animation libraries from my GitHub. These are Adafruit's LED animation libraries, but I've taken out most everything except what you need. So it fits in a small microcontroller. If you're using a faster, more powerful microcontroller, you can use the complete LED animation libraries. But I'm going to drag over the bare bones animation libraries just to copy them to the CircuitPy drive. And the animation base code is kind of the starting point for the code we'll write, so we don't have to write everything from scratch. And now, once I've copied it over, you can see the hat. I don't know if you can see the hat's not doing anything, but all we need to do, it is. Yep, it's not doing anything. It's just got some old lights on it, is change the name of the libraries file to lib, because that's what CircuitPython expects to find the libraries in, and change the name of the code to main.py, and it will start running. Great, I have it. So you can see that started up running. Now you may need a few adjustments to your code before your LED animations will start running, which is fine. We'll take a look at the code and see what needs to be adjusted. But I have set the right pins and properties for my code. So to edit the code, I'm using the Mu code editor, which I strongly recommend. You can use any text editor, but it's nice to have one that interacts with the REPL. So you can do interactively talk to your board. So if I can load my program, it automatically looks to the CircuitPy drive. And here's the program that right now is running on this LED strip hat. So let's look at some of the nice features, some of the important features of the code. The first lines just import the modules we need. They're pretty standard modules. Depending on your LED strip type, you may need neopixels. Most people will probably use neopixels, or you might use dot star. But because of the levels of abstraction Adafruit's put in their code, once you instantiate your LED pixels, an object for them in CircuitPython, you can use the same code to create the animations without having to look too deeply under the hood to see what kind of pixels you have. The next part of the code imports the LED animation modules from the LED animation library. We'll see what they are in a minute. There's an animation called Comet. There's a function called Color Wheel. And we'll see about animation sequence lets you sequence one animation after another. These next lines are blocked out. If you're using a Gemma M0, as I am, they will put the kibosh on all the memory and your code will stop running. So we're going to push this Gemma M0 to its limits for LED animation coding. So this is the part, if you scroll down a little bit, this is the part you need to customize for your board. My LEDs are connected to pin D1. And just to show off a CircuitPython feature that I love that I never knew about till I started working with Python, is if I go to the REPL and let's open up that serial window again to get a good connection. Go to the REPL, click Control-C. I can query my board. If I can't remember what pins I have, for example, if I can't remember what the NeoPixel pin is on Circuit Playground Express, I can import the board module. Okay, I can, and then you can query, do dir, take the directory of the board to see what the pins are, and it tells you what pins are on your board. So there's D1, there's my nice pin, and if you're looking for a nice pin to use, you can look at the names of your pins in the REPL. So to get back to the running program, I can hit Control-D, and the animation starts up again on the hat. So that sets up, so set the right board and the correct number of pixels for your board. If you're using a Circuit Playground Express, it's usually board.neopixel. I'm going to keep it with mine, and usually 10 for Circuit Playground Express. So make that appropriate for your board. Here's where we create the pixels object that represents our strip, either for neopixels or dot star. And here, this is the code. Now this is the animation code. That's it. That's how easy it is. This is why I love CircuitPython so much. All we've done is create a Comet object that is, you instantiate it by calling the constructor for the Comet module. You pass in your pixel strip. You tell it the speed. That gives you the delay between animation frames. So the shorter this is, the faster it is. The color of your animation, the length of the tail, because it's a comet going back and forth, and whether or not you want it to bounce. And the really great thing about prototyping with CircuitPython and LED animations is the instant reactivity of changing things on the fly. So I could change the color to yellow. I could change the tail length to 2, and I could make it not bounce. Change bounce to false. And all I have to do is hit save. And if you watch the hat, boom, that's it. Instant feedback. It's wonderful. I love it. It's great for the creative process. You can try your changes as soon as they happen. And that makes me really happy when I'm coding. So one moment. I've got a question about whether connecting to the CircuitPython REPL works in VS Code, and I'm afraid I'm not familiar with VS Code, so hopefully somebody else can answer that in the chat. I know there are other programs that can. You can always use a serial port program that can talk directly to the serial port, like PuTTY, and that will get you the REPL if you're using a regular text editor. Okay, so we've seen how easy it is to change animations on the fly, and the other benefit, I've done a lot of animation coding long before there was this LED animations library, which I love, like this headband. And timing in animations is always an issue. Especially if you want to do things like check for button pushes or Bluetooth connections, which I hopefully will have time to demonstrate shortly. So all you have to do to make your function run is repeatedly in the true loop call comet.animate. It takes care of the timing, the speed, and lets you use whatever other time in the loop you want to check for things like button pushes or interactions or function calls, anything you want. So it's super easy to make an animation. Let's explore how we can increase the complexity of our code and our project by adding more animations. Now, you can add the LED animations library has some great animations. I will run out of space on this Gemma M0 if I use them here, so we'll hold off on changing that until the next part of the demo. But what I do know that I have space to do is create a second comet animation. So, and let's call it Comet 2 and give it some different functions. So we still pass in the pixels. Let's make it, how fast are we going? We'll make it a little slower, 0.08, just a little slower. We'll change the color to red, 0. And we'll make it a little longer, and we'll make a bounce. So make it a little different so you can tell the difference between the two animations. And all I have to do now that I've created the second comet animation is change the object I'm calling animate on. All animation objects have an animate function. And if I save the code and you watch the hat, there's the new animation running. And that's pretty nifty. Super easy. But now I've got two animations. I want them both to run. Adafruit LED animation library has a solution for that. There's a nice feature called animation sequence, and you can see we imported the module for it up here. We can create a sequence of animations that plays a set of animations in turn. Oh, I got a good question. How do you tell when the board runs out of space? Let me show you, because that's actually really easy to do on the Gemma M0. So I'll tell you why. There's a reason these lines of code are commented out. If I uncomment just this one more module and try to import it and click save. All right, hang on. All right, we're not quite enough. Let me uncomment 2 because I've got at a little different space than I was before. Really? Oh, there we go. Okay, there's my failure right there. Memory error, memory allocation failed, allocating 64 bytes. So trust me, you know when the board runs out of space. And actually, if you're trying to drag and drop too many files over to it when it's a drive, just like a drive, it will tell you drive full. So you'll know it's not something you're going to run into accidentally, though it can be easy to do literally while coding just by adding a few more objects. So I'm, again, like I said, going to push this Gemma M0 pretty much to its limits, and then we'll switch boards. So let me save this, and that should get our animation started back up on the hat. Okay, so we're going to use animation sequence to create a literal sequence of animations. So all we have to do is create an animations object equal, and I do love autocomplete for real-time demoing, so I don't have to worry about spelling. And you just literally pass in a list of your animation objects and let me remember the code word here. Of course, I'm forgetting it. You need to tell it the interval you want each animation to run for before calling the next one. So the keyword is advance interval, and you just pass in seconds. So let's make each animation run for 5 seconds before passing on to the next animation. And now, instead of calling animate on our individual animations, we can call animate on the sequence. And let's save that and watch the hat. And there's the first animation, no bouncing, and count down from 5, and it should, there we go, there's our second animation. And you can put as many animations as you want in there. And if you don't have a Gemma M0, you can actually put more complex and use all different kinds of ones that we'll demo in a bit. But it's a really nice feature to have. And additionally, so you're like, great, but I don't like yellow and red. I'm a little sick of those. You can very easily do things to change things up. You can put in a callback function that this animation object will call every cycle. So let's create a function that when passed an animation object will change the color of that animation. And it's pretty easy to do. We just define a change color function. Color. It takes an argument of an animation object. And anim is our animation object. Its color property is just color. So we set anim.color, and let's generate a random color. To do that, we're going to use the purposely imported the color wheel function from LED animation.color module. So we can call that, so it's color wheel, which takes an argument from 0 to 255 and returns a hue, basically a color somewhere on the hue spectrum from 0 to 255. So we'll pick a random value. Random.randint will give us a value between 0 and 255. And that is our function. So any animation that's passed into it will change its color. So now all we need to do is get that function called. So you very easily do that because there's a hook built into all these animation objects. So if I want to just change the color of one of these animations, I can just say comet. I'll just change the color of the first one. Comet dot, let me look up the phrasing here. I always forget quite how to phrase that. It is, okay. I would know it if I weren't doing a live demo. So it's comment, add comet, add cycle complete receiver, spelled ADD, cycle complete receiver, and we pass in the name of our callback function. This registers the callback function to run after a cycle. So let's call change color. Okay, so we've added this callback function just to one of the animations, and it should change the color after every cycle. And let's see what happens. If I click save and haven't made any typos, we'll look at the hat. Okay, so there's animation. And like, it's a little hard to see because it's a little saturated, but you can see each cycle we were changing colors, but the second animation isn't because we only put the callback function on the first one. So, and if you wanted to change both animations to the same color, instead of adding the cycle complete receiver to one of the animations, you could add the receiver to the animation sequence object itself, and click save. And now at the end of a cycle of two animations, it will change the colors of both. Okay, and I have I have like 3 minutes left. So all right, very quickly, I did want to show how easy it is to connect Bluetooth to things, but I think I'm probably not going to have enough time to do that. So what I'm going to do is do a little Bluetooth demonstration, and I am actually going to upload the code. There's a little bit of it there. Well, let's see if I can find some existing code and show it off, but just how easy it is to add Bluetooth to your LED animations in CircuitPython. So we've pushed the Gemma M0 board to its limits. Now I have this edgelit spiral I made with 55 LEDs hooked up to a bigger, faster board, the Circuit Playground Express Bluefruit, which has Bluetooth built in. So if I connect this to my monitor, oops, and don't accidentally put it in. There we go. Okay, so right now it's running an animation, and I probably won't have time to code it in real time, but I might have time to show you where in the code it does interesting things. So let's load the code from this. And oh, no, I have not. Nice. So you know what we're going to do? We're actually not going to use this one because I didn't put the Bluetooth on there. We're going to use the collar I made because this has a Bluetooth board built into it. So this is the infinity mirror collar I built, and you can actually look up how to build one yourself on I have 1 minute. Okay, so you know what we're going to do? The code for this is online. It has Bluetooth, and I'm just going to do a quick demo of how easy and fun it is to change colors. So if you can see the collar running, it's an infinity mirror running LED animations from the LED animation library. I can connect to it as long as I connect to the right one. Probably not that one, this one. And pull up the controller and pull up the color picker. I can select a color and send it over to the animations. Super easy. And you would not believe how few lines of code this took. So That is, I will let you go to my GitHub. And if you go to Adafruit's Learn Guide for the Infinity Mirror LED collar, that will tell you how to make it. And it actually explains the code and how it works. But it was ridiculously easy to add Bluetooth interactive LED animations using CircuitPython. So I hope you've enjoyed this talk. Sorry, I didn't get to show as much as I'd like, but I do hope you've gotten inspired to build your own CircuitPython LED projects, because they're a lot of fun to do. And that's about it.
I'm sure microcontroller sales will have a spike after this talk because everyone was so inspired. Thank you, Debra, for such a sparkly talk.
Thank you very much for having me. I was delighted to share my projects. I really enjoyed it.
Yes, thank you. So next up, after a few minutes, we're gonna have worldwide Python communities. Learn from organizers in Africa, Indonesia, and South Korea. We'll see everyone in a few minutes. Bye.